this is Britt Caswell with another example video. In this video, I'm covering example 1 from section 3-4 in the SavvasRealize Algebra 1 textbook. So in this example, we are trying to connect sequences and functions in order to talk about them. So for part A, they give us this list, okay? They call it an ordered list because it has to be written in this order, okay? And they're wondering if it's an arithmetic sequence. So I want to start by defining what these are, okay? So a sequence is just an ordered list, like we saw earlier. Arithmetic means that it is separated by a common difference. Okay, so what that means, my pen did not read well for that. So what that means is that the jump from one number to another number is the same from each and every value. Alright, so let's take a look at this. So to go from 26 to 39, I have to add 13. Alright, so the difference here is 13. To go from 39 to 52, again I have to add 13. From 52 to 65, adding 13. And 65 to 78 is adding 13. So the fact that every time I move forward in the sequence I add 13, that is what a common difference is. Okay, so there's some vocabulary word for you. Now, to tell if it's an arithmetic sequence, it always has to be by 13. So I can't jump at different values every single time. So like, I can't do like 13, 13, 13, and then my last jump be a 5 or something like that. Then it wouldn't be arithmetic. Okay, so to be arithmetic, you have to add or subtract by the same amount every single time. Now, sequences are related to functions in that there's an input and there's an output. Alright, so let's talk about our values. We have a 26, 39, 52, 65, and a 78. Alright, these are my outputs. Okay, or my y values. Alright, so what is my input then? You might be wondering. Remember, the input is the x value. What our input is it's the position in the line. So this 26, it's in the first position in the line. So my input, my x, is 1. This 39, it's in second place in the line. This 52 is in third place, the 65 is in fourth, and the 78 is in fifth. So my input for my function is the position of the number in the line. Alright? Now this is often called the n value. Alright, so you're going to see some formulas coming up in later videos. You'll be seeing it here. So when we talk about this, we usually describe this as A sub 1. So we use A, capital A, for arithmetic. Then in parentheses, I put in the 1, saying, what is the value of this arithmetic sequence when I plug in 1? On this one, I might say A of 2. What is the value of this arithmetic sequence at the second term? So do you see how that kind of looks like your function notation with f of x? Okay. So these A values, they correspond with the 26. So I would say, for example, A a sub 1 is equal to 26. Because if I look in that first position, it ends up getting me 26. Or a sub 5, for example, would be 78, because 78 is in the 5th position on the counter. Now this type of function notation is a little weird. Okay, we don't really use the parentheses like that, except for to introduce this. What we tend to do instead is we use what's called subscript notation. All right, so if I have a of n, so a of n value, I will usually write it a with a little n next to it. Okay, so if I would, for example, write a of 5, I would write it as a sub 5 right there. And so these subscripts, they tell us stuff. So if I'm talking about a sub n, I'm talking about this term. If I want to talk about the next term, I would talk about a sub n plus 1. Now that plus 1 that's on there, it is not saying you're adding 1 to a. It is saying you are moving up 1 in the sequence. That's why it's really tiny and next to the a. If I want to talk about the previous term, I would talk about a sub n minus 1. Okay, so those are the 3 most common subscripts that you're going to see. Let's go ahead and let's take a look at another example. So it says a sub n is the value of the nth term of the sequence. Okay, and then they give us our sequence. And it says, is the domain of the function continuous or discrete? So now remember, a domain is talking about the x values. All right, continuous means that it can have decimals or fractions, okay? And discrete means that it's counting by whole numbers or counting by intervals, okay? Or like it might be like multiples of a value, so like multiples of 4 or something like that. So what we have to do is we have to look at what our input was. So remember, our domain was these counting numbers that we had up here, right? So our domain is 1, 2, 3, 4, 5. And we got those numbers because they're the position of each value in the sequence, right? We said a sub 52 is in the 3rd position. So in terms of figuring out whether it's continuous or discrete, we have to ask ourselves, is this described with whole numbers or multiples? Or can there be decimals and fractions in there? So if I'm listing off numbers like this, and I'm listing off their positions, I can't have like a 3.5 in here, can I? Like if you're in line to go buy ice cream or something, you can't be the half a person in line, right? You are either the 3rd person in line or the 4th person in line. So what that means is that this is a discrete domain. And again, that's because x is describing a position. Alrighty, so there we are. That is our introduction to connecting sequences and functions. Until next time.